today we're going to be looking at comparing linear and nonlinear functions. So our learning goal, I will identify linear and nonlinear functions from tables, graphs, or equations. And basically what it comes down to is just a couple of rules for making each of these identifications. So let's start off with looking at a table. If we have a table with our x and our y, or our f of x, let's just say it looked like this. What we're looking for a linear function is a constant rate of change. So what I'm looking at, or really I'm looking at a slope. In this case, I see that as x goes up by 1, my y is going up by 1. So each of these changes, 1 over 1, 1 over 1, 1 over 1, that's constant. So this is going to be linear. That would be a linear function. Let's look at a different one, just so you can see what nonlinear would look like. So in this case, as x goes up by 1, my y goes up by 3, and then 5, and then 7. So I can see, like, if I were thinking about the slope in this case, the slope would be 3, and then 5, and then 7. That is not constant, so this would be nonlinear. And the place that you want to be careful is sometimes it'll look a little bit different. Let's see. So here, I go up by 1, I go up by 2, I go up by 1, I go up by 1, I go up by 2, I go up by 1. So I'm looking at the change going from one x value to the next and one y value to the next. I see that I have a 1 over 1, so I'm changing by 1 for both my x and my y, and then 2 over 2. But if we go back to thinking about that as slope, 2 over 2 simplifies to 1 over 1. So this is still a constant rate of change. As my x's increase by 1, my y's are going to be increasing by 1 as well. So this would actually be linear also. You just want to be careful that you're paying attention to things like that, where your x values might change a little bit differently than what you expect. So looking at tables, that's all we're looking for, a constant rate of change. When we look at graphs and we're trying to decide if they're linear or nonlinear, it's actually even more obvious than in a table. Is your graph a straight line? If it is, then it's linear. If it's not, then it's nonlinear. So here I have a straight line that's linear. This should have been a straight line. That's linear. This graph has a curve in it. This is nonlinear. Something you can do with your tables, if you're not sure from a table if you have a linear function or not, is you can plot the points. If the points make a straight line, then you have a linear function. So it's pretty obvious when we're talking about linear versus nonlinear from the graph and from the table. The final thing that we can look at, though, is an equation. The one rule for an equation, if it's linear or not, can it be written in slope-intercept form? If an equation can be written in slope-intercept form, then it's linear. If it can't, then it's nonlinear. So a couple other things, though, that you can look at. We need to have the exponent on x must be 1. or remember that 1 is shy. We don't always see the 1. So if you have like 3x, our hidden exponent here is 1. If I am dividing by x, that's not okay. This is nonlinear because I'm dividing by x. There's nothing I can do to this to put it into slope-intercept form. If I have x squared, this is nonlinear because my exponent is squared. And actually, if I were to make a table of values and graph this, it would end up looking something like this, which is a curve. So again, it's not linear. So it's really, really easy to tell based on the graph, based on the equation, and based on the table if we have a linear function or a nonlinear function. And that is the whole lesson for today. So good luck.